All right, so honors geometry, we have a couple constructions here, 3 to be exact, involving tangent lines per se. So the first one is going to be constructing a circle inscribed in a triangle. Okay, so let's go through the process here in Desmos geometry. Okay, so let me draw my triangle. I don't care what it looks like. Okay, so I'm going to draw a circle inscribed in this triangle. So in order to do that, I have to construct the in center. The in center is the center of the inscribed circle. And to do that, the in center relates to the angle bisectors. Again, you can leaf through these slides if you want to, but they're there for you. I'm just going to demonstrate. So to find the angle bisector, there's no good way to do it in Desmos geometry. You have to actually do it by hand. So the first thing I'm going to do is grab a circle. I'm going to go down one of the angles like so, or one of the angles like so. So again, I'm very interested in these 2 points, right? Okay, so now I'm going to create this segment here, and I'm going to use the compass tool to create 2 more arcs from these 2 points. So watch. Compass, I'm going to pick this segment here. I'm going to put one on this point. Okay, again, I'm going to click the segments here and put the other on that point. And where these 2 circles intersect, that's the point I'm looking for. That's going to be the second point to make my angle bisector. Get a ray, start at the vertex, go through that point. There's the angle bisector. Go ahead and highlight these 3 circles and hide them. And there we go. That's the angle bisector. All right, again, if I move this, right, it moves with it. Okay, let's go ahead and let's do this one over here because it's a little bit further away. So again, grab your circle, click on the vertex, drag it down a little bit, hit the point tool, grab that second point. Good. So now I'm going to create a segment marking the radius of this circle, and I will use the compass tool, click on that segment on one endpoint, click on that segment on the other point. Where these 2 circles intersect, that is the second point on this angle bisector. Connect those with the ray starting at the vertex, going through that point, and go ahead and highlight and hide those circles. And boom, where these 2 angle bisectors intersect, that is called my in center. I will label that as point I for in center. Again, as you can see, if I move these angles, that in center will move, but notice that it stays on that line, right? And now I want to construct a circle. Well, in order to do the in center, you have to now find a perpendicular segment from the in center to one of the sides. So I'm going to use this side because it's simple. So I'm going to, more tools, perpendicular. It says set to a slope. So I'm going to, whatever side I choose, you can choose any of the 3 sides. I'm going to choose that side. And now I want to go through the end center, that point. So again, this angle right here is a right angle. It's perpendicular. So now this segment right here, I will hopefully, that segment right there, let's call P. That is going to be the radius of my inscribed circle. P will be one of my points of tangencies. So I'll grab my circle, the center is I, and P is the endpoint. And notice here, right, where the circle intersects the triangles looks tangent. And if I move that around, notice how the circle stays tangent. That is called an inscribed circle. Okay, cool. So again, going back to the notes, construct the in center, which is through the angle bisectors, create that perpendicular from the in center to one of the sides of the triangle, and then construct that circle using those 2 points. Okay, that's construction 1. All right, construction 2. How about the circle circumscribed about a triangle? So this one's actually a bit easier. All right, so let me get a new construction. Let me try to construct that same kind of triangle I had. So it looks something like this, I think. Okay, there. So now this one involves the perpendicular bisectors because the circumscribed circle involves the circumcenter, and that is the intersection of your perpendicular bisectors. So the Desmos geometry actually does this pretty easily, right? Because there's a midpoint. There's your bisector part. Pick 2 sides. I'll pick this side and this side, and then get your perpendiculars. So I want to be perpendicular to this side through that point, perpendicular this side through that point, boom, there is my circumcenter. We'll call that C. Remember that depending on the shape of your triangle, the circumcenter could be outside, right? So if you recall, if I make this a right angle, there's the circumcenter. If I make them all acute angles, notice the circumcenter gets dragged inside. But this was my picture. So now to find this circumscribed circle, these three vertices are all going to be on the circle. So you can pick any vertice to call point P. I'm going to call that point P. And now CP is going to be my circle's radius. Grab the circle, center on C, in the radius on P, and notice that that circle goes through all three vertices. And if I move P around, right, or if I move the other ones around, notice that that triangle stays, right, all three vertices on the circle. And that's called the circumscribed circle about the triangle. It's about the triangle because the triangle's inside and the circle's on the outside. All right. And again, if we look at the notes here, right? So step one, construct the circumcenter, which is the perpendicular bisection. Notice this one is inside the figure because it's an acute triangle. And then there's your circle that goes about the triangle, all three vertices in the circle. All right, last but not least, let's construct a line tangent from a point outside of a circle. This is a specific honors standard. It's an asterisk standard in the Ohio Learning Standards. So again, they figure honors kids should learn it. So the first thing I'll do is I'll make a circle. I don't care. And I'm going to put a point. Let's say my point's right there. Okay. So this is my point that I want to draw tangents through. And there are going to be two tangents that I can draw. And we're going to construct them both. So the first thing you do, once you have your picture drawn, is you're going to make that line. And you're going to find its midpoint. Or you're going to make a perpendicular bisector, actually. So there's the midpoint. Here's your perpendicular. And now the next thing you're going to do is you're going to measure this segment. And you're going to use the compass tool to create two arcs using this segment as the radius and that midpoint as the center of the circle. And the 2 points we really care about are here and here. Now I will erase this circle. Those 2 points are your points of tangency. So let's call this point P, right? And let's call this tangent point A and this tangent point B. How about that? And now if we connect a line from P to A, that's tangent. P to B, that's tangent. If I move A around, there we go, it stays tangent, right? And now, just to check, let's create a radius from the center to A, and let's measure that angle. If you remember the first theorem from our notes, is that when a tangent hits a radius, they should be perpendicular. And let's see, 90 degrees, done. Okay. So again, in your notes here, construct the midpoint of the segment between the center of the circle and the external point. That's your perpendicular bisector. And now you're going to use a compass, and you're going to create these 2 points. Oh, sorry. They use J and K using this length as your radius. Okay. Cool beans. Hopefully you can do this yourself on your Edge Elastic homework. All right. Thanks for watching.